Hello everyone, Duke here with a short video about gimbals and the basic setup. This is an option for one of the assignments in the AV3525 sensors class as far as configuring the gimbal to work with your aircraft. And I appreciate those of you who've already started on this and we've figured out some things along the way. This video should help everyone get on the right track and be able to configure the gimbal with your aircraft. I'm not going to walk through every single step here, but I'll give you some general tips and pointers. Part of the assignment is to do a little bit of research and figure out how this stuff works. Okay, and here we have one of the gimbals that's, we have basically about 12 of these that the program owns that are available for use in this project. This is what you might call a brushless gimbal. It's 2-axis, so we have our tilt here, and, or sorry, I guess get my camera terms mixed up compared to aircraft. I guess this is tilt and roll. Okay, so there's no third axis, and that's okay. You can just yaw your aircraft for the third axis. This gimbal would attach up to the bottom side of the front of your copter. There's those little slots in the top plate. I don't have a copter here to show you, else I would. But basically these will mount up to that front of the copter there with those 3 slots in the bottom plate of the copter. With the gimbal, it comes like this. Okay, there are also a couple other pieces of equipment you may or may not use depending on how you set things up. Okay, this is a connector here. This is can plug into this side, of course, and has bare ends on this side. Okay, that's used for powering the gimbal. And then we have a couple other things here. These sets of wires here, they're in pairs. It doesn't really matter if they're in pairs, but basically these are the sets of wires. You need 4 wires to send signal and get a ground connection between your flight controller and the gimbal. Okay, you'll see that, oops, sorry, on this side here, these sets of pins. There'd be a signal, power, and ground. We don't need power. We just need signal and ground to be connected up here on the gimbal for this to work. Okay. Also, there's a set of instructions. I'll try to upload a picture of these to Canvas since I don't have one set for every single gimbal. But it does give you some general layout here of the gimbal control board. Okay, so pitch and roll there like we're talking about. And then we have our power over here, and it does say 12 volts. As well as over here, we do want to use 12 volts to power the gimbals. Okay, there's a couple different ways you can do that, but basically don't plug it into a 4-cell battery directly, as that might damage the gimbal control board. Okay, so speaking about power and stuff like that, let's look at that for a second here. So we can take our gimbal, and we have this little plug that's from the factory soldered on here. Okay. This plug works just fine. I mean, there's nothing wrong with it. Okay, but you may choose to use a different connector for this if you're going to wire it directly to some kind of power source or something else similar. I'm going to show you a couple different ways you can do that here. If you're using 3-cell battery to fly your copter, you can just wire this straight onto your basically your battery voltage. You can wire it right into the PDB where the other things are wired up. If you just have the Pixhawk build with the 12-volt battery power running through the PDB, okay, that would be the use case there for those of you with a Pixhawk build using a 3-cell battery, if that happens to be you. If you're using a 4-cell battery, you can't do that, okay? And if you're using the Maytech flight control board, you may not be set up to do that if you're using the PDB to supply the 5 volts to the different peripherals we have, okay? So another way you can do this, okay, involves basically tapping into the balance plug of your battery. Okay, now you've probably never used the balance plug for anything besides charging before, and that's okay, right? But every LiPo battery that's more than 1 cell has a main lead, okay, and a balance lead here. And mine's already plugged into this little assembly, which I'll show you here in a minute. But the balance plug can supply some power. You don't want to pull a lot of power out of it because these leads aren't meant for high amp draw. But when we tested this gimbal earlier, it only pulled about 0.3 amps, which should be fine to run through these leads here. It's a relatively low power accessory, I guess you could say. Okay, so there's a couple ways you can do this. I have these connectors for you guys to use, and I'm hopefully going to make some of these, but if I don't have enough time to make all of them, this is basically what you can do. Okay, this connector is the opposite side that comes from the one that comes from the battery. Okay. And we look at a battery, there are the cells, 1, 2, 3, 4, and then there's a ground on the other side. So the ground wire should typically be black, and the first cell, we can say, can be red. Sometimes there are different colors in between, but you should have a first cell and a ground basically. And if you were to take a multimeter and measure the voltage across the first cell and ground, it would be the full battery voltage. So it would be, in this case, about 16 volts with a decently charged battery, a 4-cell, okay? But you can also measure the voltage from other cells to the ground, and you can measure just 1 cell or 2 cells or 3 cells or 4 cells, and you'll get basically the voltage of those cells by themselves, if that makes sense. So if I were to measure from ground to this blue wire, I should get the voltage of 1 cell, okay? And that also means I can, pull power from 1 cell. So what you can do with the battery, if you'd like, you can take one of these and you can wire up a set of leads like this one over here. Oops, I can grab it on camera here. Like this one over here, and you could wire it up to the ground and 1, 2, 3 cells, which would give you 12 volts, okay, out of a 4-cell battery, because the third cell is going to be those 3 cells and ground. That would be about 12 volts. We're not including the last cell, so the voltage doesn't go up to 16 volts. Okay? You could do that. What I'm hoping to have time to make for you guys in the next couple weeks is actually this assembly here. Okay? Rather than pulling the voltage from just 3 of the 4 cells, which, it's not a lot of power we're pulling out, but it's better to keep it balanced if we can. What I've made here, this is actually a voltage regulator, so something like this little circuit board here. Okay? If we get kind of a little bit closer here, we can see it has a voltage in and a ground, and then a ground and a voltage out. Okay, these are just little voltage regulators, and so you can wire this up to 6 to 60 volts in and ground, and you can get 5 to 12 volts out. Okay, and so what I've done in this case, I have done that with this one. It's a different voltage regulator inside there, but the same idea. I have actually just attached the voltage regulator inputs to the ground and basically the first cell here, so across the entire battery to get that full voltage, 16.8 fully charged. Okay, I've removed the other pins out of this connector, so we just have the 2 end pins, and that inputs about 16.8 volts into the voltage regulator, and the voltage regulator then outputs 12 volts. So out through here I have 12 volts coming out. Okay, and then this connector here, I'll show you in a minute. I've put the other side of this on the gimbal as opposed to this red one here, just because XT30s are more common. So I thought I'd just use one of those. So that's another way you can power your gimbal there. If you'd like to just use a small 3-cell battery from the program and have 2 batteries on your copter, that's fine as well. And then that's another way you can do it. But if you want to use the same flight battery as what you're already using and you're not flying with 3-cell, you're going to need to either do something like this, where you go from the first to the 3rd cell basically, or a voltage regulator first to the 4th cell. Okay, and again, I'm hoping to make a handful of these for those of you who want to use the gimbals here in the next couple weeks. Okay, but if you are ahead of me in that project, you can make one of these yourself. I have the components. I can help you, or you can do up to the 3rd cell there. So hopefully that explains a little bit of how to power the gimbal. Okay, once we have the gimbal powered, then it's working. It's functioning. The gimbal by itself, these ones will auto center. So if you just power it up without any signal inputs, it should go to nice and level. Okay, more or less like that. Now you do have to realize you have to balance a gimbal. It won't just hold like this by itself. It's got this humongous motor on one side, which is a big weight, right? And if you just power it up without any weight on it at all, it's just going to kind of hang like this, right? And as gravity would hang, and it's going to kind of chatter as it's trying to move, but it's not strong enough to move that over and lift that huge motor lever arm to the other side. Okay, so realize you have to have some kind of a dummy weight. Now you'll see, I'll show you right here real quick. I just made a dummy weight on this one with some hot glue stick and some nuts. Okay, doesn't really matter exactly what the dummy weight is as long as it's a decent balance. When the gimbal's unpowered, you want it to be able to balance relatively well side to side like this. So you want to put the weight over here if it's just a smaller weight, or if you have an actual GoPro or camera, you can strap on there and get it to balance when it's unpowered, and that'll make it much happier when it's powered. Okay, let's see here. So all right, so we have our gimbal set up as far as power goes. Okay, now I'm going to show you this test rig I have over here that I've been playing with this morning. I'm going to kind of move some of this stuff out of the way a little bit. I have our transmitter in here and everything. Okay, here's my super high-tech test rig. Got the gimbal strapped up there to the bottom of a chair that's upside down to hold it somewhere because I don't have a copter up here in the lab to test with. Place my battery in its secure position here. and then we're able to plug it in just a second. But we'll see here the gimbal's set up here. We have the XT60, okay, coming off the gimbal, coming off the gimbal here, which I'll plug into this in just a second into the battery power, okay? And then we have the Maytech F405 down here, okay? Now this would be very similar to how you'd set it up with a pick sock. Instead of course, extra soldering, you'd be plugging more things into the back of your pick sock, right where the motors are plugged in as far as getting those signals, okay? But I have my receiver here, okay? These leads are just powering the flight control because I don't have a battery lead connected, all right? And then we have the signal wires going up to the gimbal, okay? So it's a little bit hard to see. I'm trying to get it to focus here. Come on, camera. Okay, there we go. Okay, so a quick solder job, not my best, but we can see here on the right hand side we have these red wires, which are my signal wires in this case, going to some of these extra motor outputs. I have them going to 7 and 8. You see that row along there, S5, S6, X7, S8, S9. Those are signal pads, okay? And then these brown wires are my ground wires. I just found a couple grounds on this board and put them to ground. The ground should be common, but you just find a ground on your either flight controller, or if you've grounded things out on your PDB, you can use that as well. Of course, if you have the pick sock, you'll just have a plug that goes into the back of the pick sock with signal and ground in the pick sock. Okay, we have signals and ground basically going up to the side of the gimbal there, okay? And that's what's sending the signals on how to actually control the gimbal and move it around and stuff like that, okay? So the flight control is already powered up. Got my transmitter over here, all right? I'll try to get this in frame as I hold the transmitter up with one hand and hold this tablet I'm filming with the other hand. Let me go ahead and plug the gimbal in real quick, and we'll see it center up here in just a second. Okay, there we go, a little bit of adjustment there. And so as soon as it powers up, the flight controller is already powered, so it got signals right away, and it kind of put it into this position from where I left the knobs. We can see here, though, as I move the knobs, I'm going to try to get this all in frame, there we go, okay. As I move the knobs, the gimbal is controlling both its, I guess, tilt, and then if we can hold the other knob with one hand, here we go, and its roll. Okay, so that's working with these little knobs here that I've assigned in Mission Planner to those functions, okay, which I'll show you here in a second. But we see this little voltage regulator doing its job here. Okay, so we have the balance lead here into the voltage regulator, 12 volts into the gimbal. Gimbal is happy, and it's happy because I have this weight on there as well, so it's kind of counterbalanced. It's not getting too heavy on one side, though. If I try to max out the movement, we can get a little bit of chatter sometimes. Let's see if it'll do it. And it's holding pretty well, actually. Okay, but if you try to move it too much, sometimes it just can't hold the weight that much, and it'll kind of shake as it's trying to move, but it's not strong enough, basically. Okay, so there's that. All right, now the next question is how to set this up, right? How do we do this? Okay, so if you're using the Maytech flight controller, you're going to have to do a custom firmware, just like we did at the beginning of the class, to support the rangefinders and that kind of stuff. I have the firmware, I've built it and downloaded it, so I'll put that in Canvas for you, all right? But you do need to use a custom firmware in order to control the gimbal, because by default, the firmware doesn't include the parameters or drivers to control what Mission Planner or what ArduPilot calls a mount. So a mount is a kind of a general word they use for lots of different types of gimbals, okay? So I'll make sure and post that firmware along with this explanation when we get to that point in Canvas. But if we look in Mission Planner here, okay, let's go over to the setup page. Okay. Oh, I need to connect. Sorry, guys. Connect to the flight controller here real quick. There we go. Okay, so in the Mission Planner servo page, okay, servo outputs, we can see here these have been assigned to mount 1 roll and mount 1 pitch on 7 and 8. Okay, now I just matched up everything and went off of this page here. Okay, now I know it says it's a servo gimbal. All right, now I'll post links to this page, of course. But basically, the gimbal we're using is just kind of, we're just going to say it's a dumb gimbal. It just gets signals. It doesn't give any feedback or anything like that. So it doesn't really matter as long as we send it a PWM signal to these brushless motors. Okay, they get the signal and they know what to do. Okay, so on this page, we have the supported gimbals here. Any gimbal accepting PWM should work. All right. Mounting the gimbal, here is a typical connection for PIXOC, of course. Okay, so they're talking about ground and signal there. All right. And then as far as everyone in class, we'll want to use the section here, configuration 4.3 or higher. All right. The camera gimbal page in Mission Planner, if you come across that page, it does not work with these versions of firmware, so you can't use it. All right. You need to basically follow along with these parameters here and these parameters here. All right. We're not going to do 4.2 or lower, so don't worry about this section down here. All right. We'll see some mount parameters here. Okay, these kind of set up the gimbal itself as a device. Okay, these defaults should all work really well. I've tested all those defaults. That's what I have on the flight controller right now. And then here in this section here with the servo functions and RC options, okay, you want to remember that when you set a servo function, it's saying what is that function going to do. Okay, so in my case, I didn't have 9 and 10. If we look on the flight controller here, okay, I used 7 and 8. If we go right to left here, 5, 6, 7, 8, 9 on those S pads in the top. Okay, but 9 and 10 would be the default for like a PIXOC, as the picture shows up here. Okay, oops, let me click on that. All right, but down here we basically tell the autopilot or the flight controller what it's going to do for which outputs. Okay, so in this case, servo 9 function set to roll, servo 10 function set to pitch. Okay, I didn't have to adjust these really at all to get it to move. Now you might want to play with those a little bit as you move the gimbal around and see where its limits are. Okay, but the defaults will get it moving anyways. All right, we don't have a yaw axis on this gimbal, so don't worry about yaw. All right, and then you need to set your RC options to actually control those outputs. All right, so like for example, mount pitch. So RC6 option needs to be able to be set to 213 so it can control this output right here. All right, so for simplicity's sake, I made everything the same. I used channels 7 and 8 on my transmitter here. Okay, so I assigned these knobs to 7 and 8, and because I'd also already soldered these wires to 7 and 8, so everything was 7 and 8 for me. It may be a little bit different for you depending on how you do it. Okay, but once I've assigned these options to mount pitch and mount roll, okay, they don't have mount roll here for some reason. I think they just forgot, but it's 212, I believe, if you look in the parameter. Okay, so you'll have mount pitch and mount roll assigned to something on your transmitter. Knobs will probably be the best option if you have a couple knobs there. All right, and you'll assign those functions to do that thing, to control the mount. Let's see, focus, camera, there we go, to do the mount. Okay, so if we go over here to Mission Planner again, you'll see 7 and 8, mount 1 roll and mount 1 pitch. Now I didn't assign them in the drop down. Now you could do that. I just went straight to the parameters as I was following along with this page. Okay, but those are assigned there, right? And then my RC options, which you won't really be able to see unless you go to the parameters. Okay, let's search for one of those real quick. RC7. Okay. RC7 option is set to 212, which if you look over here is mount 1 roll. Okay, and so you can mess with channels and get the right channels you want to use and the knobs you want to use and everything, but the idea is the same. Okay, the knobs are assigned to a channel, the channel is assigned to do something in Mission Planner, and the output is assigned to actually send those signals out through those specific pads to the gimbal. Okay, so again, as we move the stick here, or the knob, we get that movement side to side. It's actually pretty smooth, and the other knob here is assigned to the other axis. Okay, all right, now guys, this assignment is meant to be a bit of research, a bit of exploration, so this is the kind of the explanation I'm giving you to get you started. There'll be some figuring on your end too, of course. I'm happy to help, but I'm not going to walk through the whole steps, all the steps to this project, as it's meant to be a bit of a research project for you, whether you do the gimbal or whether you choose to do the theoretical part of the assignment, or choice in the assignment. So hopefully this helps. I'll put up some pictures up of my wiring a little bit, and then a couple links from these pages. Thanks, good luck.